Hi everyone. In this video I'm going to work through another application of quadratic functions, and this is another one where we have to find the equation ourselves before we use it to find a maximum. So this is a Norman window problem. These window problems are really classic max-min problems. So we have a window that is a rectangle, and sitting right at the top is a semicircle whose diameter exactly matches up with the width of the rectangle. We're told that the perimeter of the window is 20 feet. And we are supposed to figure out what dimensions will admit the most light. So in other words, maximize the area of this window. Okay, so again, one of our variables we get for free. We're trying to maximize area. So let's let A equal the area of the window. So this is the whole thing. And I'm not going to go trying to pick out a second variable quite yet. I don't think it's completely obvious to me what it is so far. So I'm going to try and break this up a little more. So if I want the area of the window, I need the area of the rectangle plus the area of the semicircle. And again, whatever you want this work to look like, this is just to help you get going on a setup. So this doesn't have to be anything perfect. It's only for you. The area of the rectangle is going to be a length times width, and the area of the semicircle is half the area of a circle. The area of a circle is a pi r squared. Okay, so this is what I'm trying to fill in. I need to be able to get the length, the width, and the radius all in terms of the same variable. So two of those I see really easy relationship. The width of the rectangle and the radius of the circle are really closely related. The width is just twice as big as the radius. So I would say that that would be my first guess. I should pick one of those two things to be my variable. And I don't even think it matters which one. So let's go ahead and say this is x. And that will right off the bat mean this is x over 2, the radius. So I can start filling in. I'm going to go ahead and say that that's length and the vertical is width. It doesn't matter, whichever way you like it. And then radius is x over 2. I do still need a width. I don't have that. So this, again, if you're having a hard time spotting what you're supposed to use, go and look for what's restricting your choice. Why can I not just choose, say, that the base of the window is 2 feet and that the height of the window is 6 feet? And the answer in this problem is because we have a fixed perimeter. The perimeter of this thing, and perimeter is only around the outside. Make sure you don't count this little strip right here, the base of the circle. The perimeter is 20 feet. So as soon as I decide what x is, that's going to eat up some of that perimeter. And it's only going to leave me with a little whatever amount I have to decide how tall the window is. So I don't just get to pick how tall the window is. It's going to be determined by how big my base is and how much that leaves me out of my perimeter. So let's go ahead and do a little side work with that perimeter. I would say I'm going to temporarily give this a variable. So I'm just going to call it y. It doesn't matter, whatever you want. That the perimeter is made up of an x and 2 y's, and then half of the circumference of the circle. So half, circumference of a circle is 2 pi r, and we've already said the radius is x over 2. Okay, so the perimeter is an x, 2 y's, and 1/2 of a 2 pi times x over 2, and I know that's supposed to add up to 20. This is algebraically saying what I said in words, that we don't just get to choose any y. As soon as we choose an x, the 20 feet is going to force us to choose a specific y. So this equation is representing that. So let me simplify just a little bit, and then our goal is going to be to solve for y. Okay, so this goes away. So I have pi x over 2. However you like to write that fraction, I'm going to mush it together. So if I solve this for y, it will give me a formula for once you choose an x, how much room is left over in your perimeter for y. So let's go ahead and subtract an x and subtract a pi x over 2. And then we need to divide all of that by 2. You can leave that as a big ugly fraction for now, but I actually think I'm going to go ahead and break it up. That looks like a mess. So we can just divide each thing in the numerator by 2, which will give me a 10 minus x over 2 minus pi x over 4. Okay, so back up in the equation I was working on, this is a little bit of side work. This is the width of my rectangle. So now I end up with this kind of messy looking equation. That is the equation. I think I'm going to try and simplify it a little. In the modeling section, I wouldn't have really cared if you simplified, but here we're next going to go and try and find the vertex. So this is looking not very pleasant to find a vertex from. Okay, so let's go ahead and distribute through the parentheses. So I have a 10x minus x squared over 2 minus pi x squared over 4. And then I have a 1/2 pi x squared over 4. Okay, let's see. Still pretty much looking like a mess. What I do see here is all of that put together gives me my x squared term. So in this one, my b is really obvious. It's right there hooked to my x, but my a is kind of hidden. So I'm going to rewrite just a little bit. I'm going to say I have a 10x, and then, what do I want to say here? If I factor out an x squared, I get a negative 1/2. Remember, dividing by 2 is the same as multiplying by x, so this is the same as a negative 1/2 x squared. I think I said that funny. Dividing by 2 is the same as multiplying by 1/2, in case that's not what I said. And then I have a minus pi over 4 from this one. And then here, I'm going to simplify a little. What I really have is a pi over 8. Okay, so this might look like a terrible idea for you, but what I'm thinking here is that if I want to find the vertex, it's not looking easy to find the x-intercept, so I'm probably not going to use my trick where I find the x-intercepts and then figure out what's exactly in the middle, which means I am going to have to use the x equals negative b over 2a, and I need my b and my a. So I've got my b over here. Now I've got my a. As messy as that looks, that whole thing is my a. And I could actually simplify it just a little bit. If I multiply top and bottom here by 2, I get 2 pi over 8. So I could say that a equals 10x plus x squared times negative 1/2 minus a pi over 8. So negative 2 pi over 8 plus 1 pi over 8 is a negative pi over 8. Okay, so the vertex, almost there after all of that. We would say x equals negative b. The b is always what's hooked to your x, so negative 10 over 2a. And at this point, I think we're ready to just go ahead and plug it into a calculator. I'm fine with a decimal answer here. You just don't want to switch to decimals and do a bunch of rounding all the way through the problem, or you're going to compound your rounding error. So you want to save that up. Okay, so I have a negative 10. You can cancel that 2 out, but we'll just type it in as it is. 2 times negative 1/2 minus pi over 8. We're going to need some extra parentheses there to force this to all be in the bottom. We have to put a second set around it. So this is about 5.6. We can put a 0 on that. Okay, so the x-coordinate of the vertex is 5.6. Let's go back and read the question. So we were given a perimeter. What dimensions will admit the most light? So we've got the x. I think the y would also be useful. You can also give the radius, but I do think it's fair to say if you know that the base of the rectangle is x, you know that the diameter of the circle is x, and that's enough information for someone to go try and build this rectangle. They can cut that in half if they want. But y would be really useful if I'm thinking of trying to give this information to someone who's actually building a window. I am going to go back and get my y. So to do that, I would snag this formula right here. I would say y is equal to 10 minus 5.6 over 2 minus pi times 5.6 over 4. For the calculations, you could drop off the 0. And I get that y is about 2.8. And this should all be in feet, since units we started with were feet. Okay, so the base of the window should be 5.6 feet, and the height of the rectangular part of the window should be 2.8 feet. All right, thanks for watching.